So good morning, good evening, good afternoon, wherever you are in the world. My name is Tracey Zalk, and today I'll be presenting on systems thinking and systems dynamic modeling. The objective of today's presentation and the accompanying paper is firstly to introduce the concept of systems thinking and systems dynamic modeling, and then to provide a helicopter view of a bank of reference material. I'll also share why I think it's relevant for actuarial work. In order to do this, the presentation comprises two parts, as Ray mentioned. The first part will cover a description of systems thinking and dynamic modeling, as well as a worked example. We'll then have about 5 minutes for questions and answers, and then in the second half of the presentation, I'll contextualize modeling families, of which systems dynamic modeling is one, for actuarial work. Towards making this more tangible, I'll go through its relevance for something mega and topical, climate-related policymaking and scenario analysis. We'll then have about 5 minutes again for questions and answers. So, starting off with a definition of a system. A system is a set of interrelated elements organized to serve a particular function or to seek a particular goal. To zoom into elements, interrelationships, and a goal, the elements are the things, the people, the factories. We can see them, we can count them, we can measure them. The interrelationships are the structure. They're the rules of the game, the rewards and punishments, the prices and information signals. The function, or the goal, is the result that's being produced every time we see that system. Next, to define systems thinking. It's also known as holistic thinking, and it gives emphasis to the whole, where the nature of the whole is always different to the sum of the parts, and the essential properties of an ecosystem emerge from the interaction and relationship between parts. Finally, to define system dynamic modeling. This is an approach to real-world complex systems by means of the combination of systems thinking, computer modeling with emphasis on feedback loops, accumulation processes and nonlinearities, and computer simulation and testing. I haven't defined feedback loops, accumulation processes, and nonlinearities. Feedback loops can be both balancing and reinforcing. Accumulation processes are often represented as stocks and flows. Nonlinearities are where an impact of something far outsizes what a linear response would have been. Before going through the worked example, I wanted to give a bit of background to the project. In 1972, the Club of Rome produced the Limits to Growth report. The Club of Rome had commissioned a group of MIT physicists to answer the question of what the world would look like 80 to 100 years into the future. The MIT physicists utilized systems thinking and computer modeling to analyze the long-term causes and consequences of growth in population and the economy. In every realistic scenario, the model found that the limits force a collapse in the 21st century. A number of checks of the model have been done, which look at how well multidecadal data compare with the projections of the model. And unfortunately, the data corresponds remarkably well with the projections. The worked example of the country resource maps, which we're going to discuss, is one of the outputs from the Global Resource Observatory project. This project followed on from a report which the Institute and Faculty of Actuaries commissioned into the implications of limits to growth for the actuarial profession. The Global Resource Observatory project aimed to provide granularity to limits to growth work, specifically at a country level, but within the global context, and at a shorter time horizon of the previous work, so around 5 to 7 years. Here is the blueprint for developing a systems dynamic model. This worked example is systems thinking rather than a systems dynamic model. So it's a good indication of the process, but it's not going to be comprehensive in this way. So starting off, similarly to many undertakings of model development, we start off with the question that the model or analysis is intended to answer. In this case, it's which countries are politically fragile. That helps set the boundaries. And these get set to, firstly, meeting basic needs of a population. Secondly, having a credit line as a backup for shocks. And then finally, having a level of societal cohesion. The way the metrics have been illustrated is what enables consideration of feedback loops, bounded rationality, and nonlinear decision rules. It also allows for physical and information delays. It enables structures to be realistic rather than stylized, and it lends to physical laws being inherent. Crucially, it enables us to seek tipping points and shifts in feedback loops. Previously, feedback loops and nonlinearity were defined, but bounded rationality and tipping points haven't been yet. Bounded rationality refers to Simon Hubert's work from 1957, where he identified that people will neither have access to all relevant information nor perfect computational abilities. Tipping points can be summed up as thresholds, after which behavior is non-linear. Before we go through the maps, I'll talk about why the metrics selected were the ones chosen. So coming back to the question, which countries are politically fragile in the near term and at a country level, but within the global context? The first set of metrics were chosen to identify any issues with meeting the basic needs of water, food, and energy. The next set of metrics were to represent potential future credit line in order to purchase in basic resources if they were needed. The last set of metrics were to get a sense of societal cohesion and whether those basic resources would be distributed in a somewhat functional way. Snapshots were provided at the points of 2000, 2005, and 2010. This was in order to see if there were trends. In keeping with the ethos of feedback loops, while we look at the maps, please can we keep in mind the situation and responses of geographical neighbours, trading partners, and other countries with whom there might be a historical, a cultural, or other link. On to the first map of water. What this shows is a country's self-sufficiency from annual rainfall and river flows. Next, moving on to food. This map shows consumption versus production of food. It's essentially whether or not a country is reliant on imports. And it would be remiss of me to say that there are nuances with these. For example, within a country, as well as seasonality, and across essential crops. The next three maps are for oil, gas, and coal. And these show how many years left a country has of each of these, depending on its current consumption of them. If we think back to the stocks and flows, which were mentioned earlier, this is a good example of that, where the reserve is the stock and the annual consumption is the flow. So here's the picture for gas, and here's the picture for coal. Then we move on to the future potential credit line, which is what would likely be needed in the event of a shock. It won't be sufficient. There will still need to be networks and there will still need to be infrastructure around it, not to mention other countries not putting in trade embargoes, but it will likely be needed at a minimum. Here's an indication, as at 2010, of government, and the next map will be of private debt. And it's worthwhile saying that the absence of data is notable, and there is information in no information. Clearly, these pictures would have changed following COVID. For the final set of slides, which are intended to be indicative of societal cohesion, these are income inequality and under 5 mortality. Under 5 mortality is seen as a reasonable proxy for basic infrastructure and social and community safety nets. That takes us to the questions and answers for this part.
Does anyone have any questions they'd like to ask at this time? I do have. Let me just go to you first, and then I'll ask a question. Go ahead.
Oh, Charles Hett here. Thank you, Tracey. It's very interesting. Do you have a sense how much work is involved in creating the maps? Because I think one of the things that's really interesting is actually when you see maps, but how they change over time. You know, in climate change or ice flows and things. Is that something that's possible, or is that just too resource intensive? Because that would be something that would interest me.
Thanks, Charles. It wouldn't be too resource intensive. It's just a question of the fact that the project has ended, so that there isn't anyone actually doing that. But one of the main parts of the project was to actually bring together a whole bunch of open source data so that people could replicate that in future. So yes, it is quite easy to do. And one of the prompts that I have there is actually almost justifying why I'm showing you maps from 2010 when we're sitting in the year 2023. And the first part of that answer is we published these in 2014. That was obviously pre-COVID and pre the invasion of Ukraine. And I think that those two events alone have shown the usefulness of this approach. And so it's a way of demonstrating the value of that. Also, these maps will show that there are clear trends that seem to be that things seem to be moving in, and they're not really the direction that we'd like them to be moving in.
Tracey, I'm going to ask a quick question. You mentioned fragility, and the sort of father of fragility is, Taleb, who, he was the guy who wrote The Black Swan, and his theory was basically that systems which are frequently stressed are more resilient, and the way you actually see systems likely to collapse is based upon how much they've been stressed or how much volatility has been artificially suppressed. And I just wondered if any of this relates to any of his work, because it's going to be a different perspective on fragility that you're taking.
Yeah, so I think it's a really interesting point, because I think this has really differed across countries, and it might even be in the data that we're seeing from Hervé and that. There's been a lot of bailouts, and in some ways that can be interpreted as not letting something run its course and not building that resilience. And then in a number of countries, there have been no bailouts, and things have been extremely dire. So yes, fragility and resilience are really intertwined here.
So I saw Rick's hand first. Might be my eyes, but Rick, you go.
Thanks, Ray. I just want to make a comment and then ask a couple of questions. The comment is that I'm really relieved to see a presentation on systems thinking, because I think it underlies how I got taught as an actuary some years ago, not as long ago as Ray got taught, but quite some time. And because I really appreciate it, because I think it's going back to what I saw as the roots of the profession.
I agree.
And so my question is, for some ways we exist as a profession because data doesn't have reliable predictive propensities. And I wonder if it just follows on a bit from Charles's question too, around are you able, is the reliability of data or the unreliability of data or scanty data something that you can allow for in the sort of the work, the approach that you're taking, the modelling approach that you're taking?
Thanks. So I believe it does, and I think actually it's not only the unreliability of data, it's also whether or not the recent past will be a good guide to the near future. So I'll let Rick answer.
Keep going.
Pardon?
Keep going.
So yes, it does, but it does rely on expert judgment and other aspects. So there are always trade-offs.
Yeah, and that aspect of relying on expert judgment, again, I think reflects the actuarial role, so I really appreciate it. Your approach seems to allow for stuff that's not in the data, which I think is a really important thing that, it's a really important element of actuarial thinking that I think has got lost in a lot of modelling, real-world modelling processes, such as GFC.
Well, on that, I'll hold your question until after Tracey finishes her next segment, because I'm mindful of showing her the courtesy of having your time for your segment.
Thank you.
And then we'll come back to your question, if that's okay.
We should definitely have time.
We will. You know me, I stay on time.
There we go. So on to part 2, where I'll outline why I think that modelling families, of which systems dynamic modelling is one, are relevant for actuaries. And obviously I didn't know that Rick was going to ask that question, because that sort of answers it anyway. But I'll provide a helicopter view of 2 modelling families which have been used for climate-related policy making and scenario analysis. And then again, there'll be about 5 minutes for questions and answers. The paper outlines 7 modelling families utilised for policy making and sometimes for other purposes too. Policymakers and other market participants utilise these modelling families, and to varying degrees, it sets the operating environment in which actuarial work is applied. Actuaries also utilise models for their work, and that impacts on others. The 7 modelling families outlined in the paper are listed on the screen. First and foremost, I want to acknowledge that this list does not include Indigenous approaches. This is only because, thus far, to my knowledge, they haven't been utilised for policy making. I think that they should be looked into and at a minimum considered. I think that there's a reasonable chance that they would have consistencies with systems dynamic modelling. From the list on the screen, the 2 modelling families which I'm aware of being utilised in actuarial work are econometric ones in terms of liability modelling and potentially backtesting asset valuation models, and generalised equilibrium models, or models which are consistent with generalised equilibrium models for asset modelling. I'm going to focus on the 2 modelling families of integrated assessment models and generalised equilibrium models. This is because ensemble integrated assessment models and generalised equilibrium models are utilised for climate-related policy making and have been repurposed for use in financial sector climate-related scenario analysis. Integrated assessment models are what are used in IPCC reports, and they have been used for climate-related policy making. Integrated assessment models build on generalised equilibrium models, but they integrate in energy and climate modelling. The way integrated assessment models incorporate the damage done to the economy is through what's known as a damage function. I said that integrated assessment models build on generalised equilibrium models. Generalised equilibrium models are how neoclassical economics gets represented in model form. Fundamental assumptions include, firstly, the existence of stationary points in the economy, secondly, perfectly rational economic agents, and thirdly, that equilibrium prices clear markets. In terms of critiques of integrated assessment models, Lord Stern and Professor Joseph Stiglitz have reviewed integrated assessment models which have been used for climate-related policy making. In the references section, I provided links to 2 of their papers which outline their analysis and conclusion. I'll draw out one specific point because there's an actuarial link. Lord Stern and Professor Stiglitz question the appropriateness of using a cost-benefit approach for what is in effect an existential risk. 2 actuaries, Nick Silva and Oliver Bettis, have co-authored a paper with, I believe it's Simon Dietz, and the paper is called Risk of Ruin. Essentially, they say that we're taking risks with the planet that we wouldn't and don't take with the solvency of an insurance company. Professor Steve Keen has provided a body of work analysing not just the model used for policymaking, but also the ones which have been repurposed for financial sector climate-related scenario analysis. And I highly recommend looking into these. His critiques can be summarised under the headings of false assumptions, unsound data, and inappropriate functions. I want to draw out one particular critique because it links in really well with the country resource maps that we looked at. This is around how the damage function has been calibrated. One of his insights is that space has been extrapolated to time. And by that I mean that in order to estimate the impact on GDP of a temperature change, a cooler and a warmer state or country was looked at. And then the differential from that was extrapolated over time. The reason it links back with the country resource maps that we looked at is that if we were looking at those countries or states in the context of what else was going on in the world, we would see whether or not other countries were also experiencing food issues at that point in time, were also experiencing other events, and whether or not they would actually be able to buy in essentials, and whether or not there could be non-linearities. The two papers on the screen provide very useful comments around cautions around the use of these ensemble models. Moving on to generalized equilibrium models. Following the global financial crisis, neoclassical economics and its tools, including generalized equilibrium models, came under substantial criticism. Criticisms of general equilibrium models included the fact that they generally exclude a financial sector and oversimplified assumptions in respect of rational expectations, representative agents, and equilibrium prices clearing. Whilst I'm pointing to a range of criticisms and limitations, I'm not suggesting that we don't use them. What I am saying is that in light of those limitations, they are insufficient on their own and for certain purposes. So, rather than just say that and leaving the space blank, there are alternatives. And a paper by Dr. Sarah Hafner and her colleagues provides a review of the modeling families of econometrics, system dynamics, and agents-based modeling against the range of the criteria listed on the screen. I highly recommend this paper and considering whether these attributes are necessary for the purpose to which the model is being put. The presentation began with an explanation of a system from Danilo Meadows, and I'd like to conclude with a quote from her. The world is a complex, interconnected, finite, ecological, social, psychological, economic system. We treat it as if it were divisible, separable, simple, and infinite. Thank you.
I'm happy now to go back to a question that we didn't get to last time, if you'd like to ask it.
Yeah, I might be missing the point, but the metrics that were used for this analysis, I know a lot of them were like resource-based, water, gas, oil, etc. And then you jumped to income inequality, child mortality. Would something like the HDI, Human Development Index, be something that should be used, or is this completely, or is the basically, are we trying to find the limits on a global HDI, or why would it something like that not be included in such an analysis?
Thanks. So the way that the maps were presented will hopefully answer that. And the point of it was really to show at a country level where that country was, but in the context of what was happening globally, as well as with its geographic neighbours, as well as trading partners in other countries. So there are a range of metrics, and you know, there will always be trade-offs around data and that type of thing. But the point of it was just to really separate the signal from the noise and say, well, can you really have a functioning country if you do not have a level of sufficiency around water, food, and energy? And then to say, well, there can and will be shocks, and if that happens, first and foremost, do you have the money to buy in essential resources? And then lastly, even if you have done that, what are the chances that it will actually reasonably get to who needs it in society? Does that sort of answer?
Yeah, very much so. Yeah, thank you.
Thank you.
Okay, well, I would like to ask one question, Tracey, because it's a really good one, and because you suggested it, that's why I'm going to say it's a really good question. But systems thinking is something that is not well taught in the current actuarial syllabi. As Rick and I would remember, it sort of was back in the days before we had calculators, but the days before we had computers and things. But if you had one resource and somebody had, say, a 40-page limit, and wanted to get, kind of an introduction to this topic, again, enough to just be dangerous, is there a particular thing that you'd recommend people read to just, aside from the Wikipedia article, which I assume you got a better one than that?
Thanks. I would recommend Danilo Meadows. So there's a project and an institute that's dedicated to her. And there's a particular article on the leverage points in a system. And I think that will just resonate with people. And I think it's a really good gateway to the whole space.
Fantastic. Well, tell you what, Rick, go. I was going to let you sit down since you've been standing up for a half hour.
One of the interesting challenges we face, the existential problems, is to identify potential tipping points. And I think I just want to understand, you're saying in the modelling approaches you're applying here that is one of the aims is to be able to, predict those tipping points and what are the potential drivers that would lead us there.
Yeah. So I think I'd answer in two parts. The one part is I think just going through the process itself would help surface what those could be. But I really think where I'm coming from in terms of suggesting this as an approach is to try and keep us away from those tipping points. I think what I'm suggesting is that if we were using this type of approach, we wouldn't even come close to tipping points because we've been thinking about things in a holistic way.